The air in the forge tasted of iron and oil. Red-orange tongues licked the ceiling, while the shop lights hummed like a distant swarm. Sparks rose and fell in brief constellations as a hammer struck plate, and the floor beneath their boots thrummed with the slow, stubborn heartbeat of the plant, a giant machine learning to keep time. They were trying to teach a body of metal to protect other bodies, to bend and hold where it should shatter, to become a machine that might change a war. If this kind of engineering story interests you, stay with it to the end. And if you appreciate the craft and the people behind it, subscribe and leave a like. The factory sat along a river, a low complex of brick and sawtooth roofs, its windows dark with soot from years of welding. Inside, men and women moved through the workshops with the quiet concentration of people who had been working in the same rhythm for decades, a rhythm that could be accelerated at a day's notice when orders came from the military. In 1942, after the first months of shock and scrambling, government contracts had poured in, and so had a kind of moral urgency that compressed schedules and blurred the distinction between day and night. For some of the workers, the plant had been a place of steady pay and predictable routine. For others, it had become a crucible in which devotion and dread mixed like molten steel. The project that drew such attention was not a neatly named program with glossy renderings. It began, as many wartime urgencies did, as a small, stubborn problem. The Army needed armored mobility fast, and the official supply of armor plate was thin. The higher priority contracts meant that new, rolled armor steel was reserved for large plants with rolling mills. The smaller shops that dotted the industrial belt were left with scraps and rejects. In one assembly bay of modest size, a cluster of engineers and machinists decided to do what the books did not advise: build an armored vehicle from what they had on hand. At the center of that cluster was Frederick Brackett, the quiet man engineers trusted when a calculation wavered. He spoke in careful, measured sentences and preferred to let diagrams and test results do the arguing. Brackett had spent a lifetime around metals, first as a pattern maker, then as a metallurgist, learning the character of alloys the way a musician learns an instrument, by listening, by testing, by touch. He could name the temper of a piece of steel by the sound it made when struck, and would sometimes close his eyes over a freshly formed weld as if to hear the metal settle. Opposite him, in the more immediate, impatient way of youth, was Samuel Ortiz. Ortiz had come from a neighborhood where men learned to fix engines before they learned to walk. He had a restless, hands-on intelligence. If a part wouldn't fit, he would file at it until it did, then sleep on the bench rather than give up.
Where Brackett moved slowly with the weight of experience, Ortiz moved fast with a faith in improvisation that could be spectacularly useful or dangerous. Between them stood the problem in its most basic form: how to make armor that would stop a shell or a machine gun from scraps of mild steel, plate rejected for other uses, and leftover castings. The options were blunt and risky. Harden the surfaces through heat treatment. Shim and layer plates to add thickness. Reinforce with internal framing, and above all, devise a suspension and drivetrain that could carry the weight without shedding a track in the first mile.
They had to ensure that the chassis, made of patched components, did not flex in a way that would rip welds apart or break axles. Each decision carried consequences. A wrong tempering cycle and the plate would become brittle. Insufficient welding technique and seams would open under fire and shock. The margin for error was small, and the human cost of mistakes could be high. The first thing Brackett told Ortiz on the evening the blueprints first took shape is to know what failure looks like. We don't guess at failure, we make it. We learn it until we can predict its next move. Ortiz wiped his hands on his shirt and laughed, a quick sound that did not dispel the tension. We make it, then make it keep quiet, he said. He could not help but smile at metaphors when stress mounted. For him, the metal was stubborn but honest. It would tell you what it was going to do if you hit it hard enough. Their team grew into a small, informal fraternity. There was May Turner, a welder whose steady arms had been steely since before the war. She refused to let the heat sway her concentration, and she kept a strip of cotton by her cheek to wipe the sweat away. There was Joe Kaspar, a pattern maker who could sketch a bracket from memory and then carve it from wood in the time it took someone else to run a lathe. And there were the test cell crews, men accustomed to the acute frustration of engines that would not run. They learned to carry disappointment like a tool and hand it back to the engineers, polished and useful. Their first prototypes were, by any conventional standard, ugly. The chassis came from a truck with a broken frame. The engine was a repurposed power plant taken from a surplus tractor. The armor was layered from older shipbuilding plates and cutaways from carriage parts, riveted and welded together in a patchwork that resembled a quilt of hard metal. They fitted a driver's compartment with a slanted front plate and made a turret from the thickest portion they could salvage. Tracks were forged by taking spare bands from industrial conveyors and soldering teeth to them. There was improvisation in every seam. Clamps used as mountings, steel bars reshaped into torsion arms. It would not satisfy the official inspector's eyes, but it was honest. An engine of necessity.
Engineering in wartime is a particular grammar of compromise. Choose the least bad option and make it safe. The team made lists, laid out the risks, and then began a series of tests that were equal parts problem-solving and apprenticeship. They learned how different scraps of steel reacted to heat. Brackett taught them to read a metal's surface like a map. A ripple in the billet could tell you about rolling direction. A faint discoloration might indicate a furnace too hot for uniform tempering. When the first armor plate warped after quenching, cutting the silhouette of the hull, they learned to anneal in stages, to let the metal breathe out its stress slowly. When a weld cracked under torsion, Malie adjusted her bead, playing with speed and filler composition until the seam sang a tone that promised cohesion. Not all lessons were technical. A day in the shop often ended with a quiet recognition of the stakes. The workers' letters, when they arrived, served as small, sobering reminders. Ortiz carried one folded into his toolbox for weeks. A short note from his wife about their son learning to tie his shoes. The engineers sometimes read the dispatches from the front that came through the plant's bulletin board.
Not for tactical detail, but for the human shape behind the numbers. It was easy to measure a rivet's shear strength in pounds per square inch. It was harder to measure what a mother on a farm would feel if the delivery that engine promised never came. Failures piled up. On one cold morning, as the team ran a drive test on the makeshift track outside the plant, an axle bearing seized and a wheel sheared, launching the tank into a lurch that cracked the welds around the fight compartment. The metal complained in a sound like a bone under pressure, and the men stood back, stunned, counting themselves lucky. In the aftermath, Brackett sat with the broken axle and a file, feeling the surface with his thumb and frowning. They had underestimated compound vibration modes, the confluence of engine harmonics and track ripple that, at certain speeds, amplified stress at bolt joints. The fix required rethinking the entire suspension. Add dampers, reroute load paths, increase redundancy. Each failure demanded new materials or techniques that the supply system did not prioritize. The factory's procurement officer learned to be clever. He traded with neighboring plants, bartered for surplus springs, and sent workers on scavenger missions to rail depots, where abandoned brake bands and fittings could be repurposed. It was a network of thrift and tenacity, the wartime economy rendered down to the scale of a single bay. When the team found a cache of heavy rivets destined for a shipyard, they celebrated quietly, the way fishermen share a catch. Alongside the practical improvisations, there was a subtler engineering conversation: how to make armor from what was not armor. Heat treatment could change a mild steel surface by creating hard, tempered layers.
Brackett proposed a process of differential hardening. Induce a martensitic skin on the outermost layer while preserving a more ductile interior. The idea was to allow the outer layer to shatter a penetrator's tip while the interior absorbed energy without fragmenting. It was a compromise between hardness and toughness, and it required precise control of quench rates and tempering temperatures. Think of it like making human bones tougher, Brackett explained in a workshop meeting, tapping a small rounded plate. Too hard and it snaps, too soft and it bends. Somewhere in the middle, it gives just enough to stop the thing that hits it. Ortiz, always practical, asked about scalability. We can prove one plate in the lab, but what about 10,000? What about an entire hull? Brackett's eyes narrowed. We don't get to 10,000 in one go. We get there one piece at a time, testing, measuring, adjusting. If we make a rule out of each lesson, we can repeat it. Tests were methodical and relentless. They fired inert projectiles at scrap sections in a makeshift range behind the plant, noting fragmentation patterns and delamination. They subjected welded seams to cyclical load testing and monitored for micro-cracking through dye-penetrant inspection. They carried out hardness surveys with a Rockwell tester salvaged from a closed machine shop. When they saw a flaking pattern that suggested grain boundary embrittlement, they adjusted the alloying elements in the filler rod, adding a trace of nickel to resist the segregation that caused weakness. Many of these adjustments were small, 0.1% of chromium, a slightly slower cooling curve, a change in lap joint geometry. Their accumulation made the difference between a hull that would bend under stress and a hull that would hold. The months that followed contained sequences of failure, followed by analysis,
followed by small, sometimes boring adjustments. Yet in wartime, boring adjustments were the sinews of survival. The personal cost of this labor was not abstract. Workers lost sleep. Many sent money home and lived in crowded boarding houses. Some were injured in accidents that were not gruesome in description, but consequential in their disruption. A hand burned, a thumb crushed when a strap slipped, a back strained by lifting a casting. These were recorded in the foreman's log with solemn brevity. J. Rivera, contusion, 3 days light duty. At night, in common rooms and on porches, men and women spoke about what they were building and what it might mean. Conversations ranged from the practical, will it get a crew home alive? To the moral, are we making something that buys lives or takes them? Safety practices evolved as they learned. After an incident with an exploding spring clip that sent shrapnel across a bay, the team instituted new shields for workers and redesigned the mounting points to ensure a controlled failure mode.
The foreman insisted on written procedures for hot work near flammable residues. These measures were small, but they mattered. In a factory that turned scrap into implements of war, prudence often saved lives. As the tank took shape, questions of mobility and power loomed large. A heavy, armored hull required a power plant that could move not just on roads, but across churned fields and muddy tracks. New automotive engines strained under the load, overheating and suffering severe gear wear. The team experimented with cooling system redesigns, larger radiators scavenged from obsolete equipment, baffles to direct airflow, and oil coolers that used discarded piping woven like veins under the engine. A borrowed centrifugal supercharger found tucked in a crate offered a hint of extra torque at low RPM. Adapted for duty, it alleviated the engine's desperation on hills. Transmission and braking were often unsung heroes of armored vehicle survivability. The team learned to favor lower gearing and robust brake drums that could survive the stress of sudden stops on inclines. Track design underwent iteration after iteration. Wide bands reduced ground pressure but increased weight. Narrow tracks were lighter but risked sinking. They settled on a compromise that, in field conditions, proved acceptable, though far from ideal. When the assembled vehicle finally rolled out of the bay for a controlled run, the air in the shop tasted of expectation. Workers lined the doors, toolboxes at their feet, faces smudged with grit and the thin sheen of sweat. Brackett and Ortiz rode in the cab. May rode with the test team in a support vehicle. The tank moved with a lurch and then a rumble that settled into a cadence, the labor of the shop coalescing into motion. The first trial was short, but the test track's shallow grade and packed dirt gave the team data: speed curves, suspension response, cooling stability. Sensors then were simple: a crewman with a stopwatch, a sheet of notes, a thermometer locked on to the radiator housing. Yet, even as triumph warmed the bay, the plant knew that the machine's purpose carried a broader, heavier story. Tanks were weapons that delivered force. They were also shelters and transport. In the weeks after the first successful trials, news arrived from the front in clipped dispatches and in the faces of returning mechanics who spoke of cities reduced to ash, of entire neighborhoods awash in smoke.
The factory's sideboard of trophies, greased bearings, a flawlessly machined bracket, sat beside plaster casts and photos of service members. The men who labored did not all share the same view of their work. Some saw their efforts as a necessary contribution to a defensive struggle. Others sometimes had nights when they wrestled with the moral calculus. Brackett kept public silence, but in private letters he wrote of a responsibility to do the work well so that whoever rode in the machine might have the best chance of survival.
Scale up began quietly but inexorably. The plant expanded a press line, rearranged benches, and trained new hands in welding and acceptance testing. Women moved into roles that had been traditionally male-dominated, skilled in seam welding and plate finishing. The assembly line's tempo increased. Frames were jigged, plates welded in sequence, tracks assembled in sub-assemblies. Quality control grew rigorous. Each hull panel entered a gauntlet of inspection, where X-ray plates were consulted, if they had been available, and die checks performed. The procurement officer's patience paid off as other plants began to exchange materials at scale, and the logistics of feedstock slowly improved. Production introduced its own esprit de corps and its own cruelties. The factory filled with the sound of presses, the chatter of rivet guns, and the whine of grinders. Men and women learned to read one another's faces for signs of fatigue. Brigades of workers would rotate to avoid repetitive stress injuries. Foremen learned to spot early signs of burnout. The plant held nights where families were invited in to view the progress. A small ritual of connection that made the abstract product into something immediate for those who had hungered for a tangible link between factory and front. As vehicles left the plant, they entered the foggy realm of operational use. Documentation recorded their deployment in cautious terms. Training units accepted some of them. Others were sent for evaluation. Reports indicated variable performance. In some conditions, the improvised armor performed admirably, stopping small arms fire and shrapnel. In others, especially against shaped charges and heavy artillery, the limitations were stark. The feedback cycle between the field and the factory intensified. Engineers crossed muddy fields to see the machines in action, to talk with crews about what happened under fire. A gunner might point to a seam that had split after a hit. A driver might describe a bearing that had begun to smoke after an hour of operation. These accounts shaped revisions, thicker reinforcements at critical points, altered turret geometry, additional baffles to protect fuel tanks. One particularly sobering report came back from a coordinator who had observed urban operations where incendiary devices had created firestorms that engulfed entire quarters. The improvised armor performed as designed in some instances, shielding troops from small arms and fragments. But the same protective shell could not insulate against the arithmetic of large-scale conflagration. The moral calculus hardened into a phrase repeated in staff meetings. Our machines extend reach. What is reached is up to others. Brackett, who kept his comments measured, insisted that engineering could not be neutral in its consequences. The team must do its utmost to help those who would be protected by the machine, while acknowledging the larger context of its use. The human stories threaded through production were intimate and stark. Ortiz's son grew taller in photographs he sent home. May's brother returned from service with a limp and sometimes visited the shop in the evenings, leaning on a bench to watch the men and women weld the next component. Joe Caspar, who had been a solitary craftsman before the war, found delight in teaching apprentices to make patterns. His hands moved with a generosity that made him beloved. Not all endings were happy. The foreman's daily log kept a ledger of absences that tracked more than illness. It recorded men transferred to hospitals, men who never returned from the line. These quieter tragedies were not graphically described, but were present in the cadence of the plant's social life. An empty stool at a lunch bench, a toolbox left in a locker. Brackett's arc reached a kind of private culmination one summer morning when the team prepared for a full-scale endurance run, a long, continuous test designed to push the vehicle across the full envelope of its intended use. The weather was raw. The sky hid its temper behind a sheet of gray. The test track had been widened and reinforced, and the maintenance crews had readied spare parts. The factory gathered at the edge of the field like a congregation, not to worship, but to witness. The endurance run began with a rattle and a cough, and then settled into the machine's voice. It climbed, descended, crawled over ditches that had been laid to simulate battlefield obstacles, and ran through water crossings. Sensors were rudimentary. A man at the radiator rating, another with a stethoscope listening to bearings, and Brackett with a clipboard full of marginalia. For hours the tank held together, its patched armor taking impact, its engine resisting the heat. At a series of simulated engagements, inert munitions struck plates. The crew reported shrapnel strikes that left indentations, but no catastrophic failure. The endurance run lasted longer than any single previous test, and as sunset slid across the field, the team allowed itself a careful, measured sense of relief. Relief, however, did not dissolve into triumph. The fatigue and the quiet knowledge of what the machine represented remained. Brackett walked the length of the machine with May at his side. The hull had dents the toll of impacts. The tracks bore the abrasions of hours. Brackett laid his palm flat on the plate and closed his eyes. "This will keep them safer than they would otherwise be," he said, finally, not boasting, but noting a fact. "It is not all we wish it to be, but it is something. We made something that did not exist." May snorted softly, a sound that could have been a laugh or a sigh. "We made something the best we could. That ought to count for something." The climax of their story was not a cinematic charge across a battlefield, but a meticulous, protracted victory in the mathematics of metallurgy and the stubbornness of people. The first sustained endurance run was the proof of a chain of marginal gains, every small fix telescoped into reliability. After the war, the plant's rhythm altered. Orders slowed, then tapered to a trickle. The workforce shrank as contracts dried up and men returned to civilian life. The tank project, born of scarcity, survived in a handful of preserved vehicles, in maintenance manuals that now served as technical curiosities, and in the memories of those who had labored long hours beneath fluorescent lights. Brackett eventually left the plant to teach at a technical school, carrying with him the lessons of tempering that were as much about circumstances as chemistry. Ortiz returned to his neighborhood, opened a small repair shop,
and later told his son about the way the metal sounded when it cooled. The plant itself changed purpose over the decades. Where once conveyor belts had hummed and press brakes had flexed steel into functional curves, new businesses occupied bays, and the smell of oil gave way to the sweeter tang of paint in some corners. Some artifacts of that wartime urgency survived in local museums. A fragment of a track, a radiator, a rivet gauge, each with a small card that explained its provenance in sober language. Visitors who paused to read stood for a moment at the intersection of craft and history, acknowledging both the ingenuity and the moral complexity. The legacy is not tidy. The improvised tank embodied an engineering triumph of adaptation, resources stretched, ingenuity applied, lives safeguarded in certain situations. But it also sits within the broader, darker ledger of war. Machines that protect can also enable. Technologies that preserve can also destroy when pressed into service for offensive aims. Brackett had been clear-eyed about this. After the war, he wrote in notes that were more reflective than doctrinal. The engineer's responsibility, he suggested, was to be literate not only in materials and mechanics, but in consequence. We have to know the reach of what we build, he wrote in a fragment, and be brave enough to measure ourselves against it. There is a final, quieter image that often appears in accounts of industrial life: the silence after the roar. In the empty workshop, a torch lies cold, a grinding wheel stands still, and traces of soot mark the hands of those who left. For the people who built the tank from leftover scrap steel, the silence signaled both closure and persistence. Their techniques, their small improvements, and the comradeship persisted in the apprentices they trained, in the repair manuals that survived, and in the humility etched into their practices. The heart-like cadence of the plant gave way to another life in other forms. The furnace cooled, but the lessons endured. If you find this story compelling, if the mixture of craft, grit, and consequence resonates, consider subscribing and sharing.
Tell us in the comments, do you see technology more as a savior or as something that enlarges human agency in ways we must guard? Your thought matters, and it deepens the conversation those workshops began. They had not built the perfect tank, but they had built a bridge between scarcity and necessity. The machine, for all its patched plates and improvised mounts, became an embodiment of a wartime ethic. Make what you can, make it better than it was yesterday, and pay attention to the people who ride inside. Night fell over the river and the low roofs. Somewhere in the town, a gramophone played an old tune, and a family leaned into the safety of each other. Inside the factory, a bench light glowed for a time as Brackett annotated a ledger, his notes small and careful. Outside, the stars were indifferent. Inside, the work had made them a little more human. Brackett closed the ledger and set his pen down with a deliberation that had nothing to do with fatigue and everything to do with ritual. The scrap of paper he'd been trying to make neat for an hour was not a ledger entry so much as a test of his own steadiness. Small loops of ink that said in a private hand that he had been careful with his days. He snapped the bench lamp off, and for a moment let the darkness move across the room like a tide.
The light left a halo on the table where he had drawn a line, and then, like all lines that mark the end of something, it invited him to imagine what began next. The technical school was what began next. He taught metallurgy the way someone tells stories by their simplest truths: heat and time, and the respect due to both. He spoke in the lecture hall and at the workbench of temper and of patience. Students watched him file a sample down to its grain and then hold it up to the flame until it changed color. They liked the theatrics, the small flares of orange and blue, but they learned the discipline behind them, the patience, the measurements, the small corrections that an untrained hand would have missed. Brackett insisted on errors being visible. He taught them to catalog what failed and why. His notebooks filled with the ghosts of misapplied processes, cross-sections, notes on quenching media, the names of oils and salts that had worked, and those that betrayed optimism. An engineer, he told them once, when a young man asked whether all of their work would someday be read by historians, is a person who promises behavior. We make things that will act in certain ways because of the things we decide now. The choice is not only what we build, but what we intend it for, and how we stop it from becoming something else. Students, in turn, brought the world into his classroom. They bore scars of factory floors and the smell of solder. Children who have left school too soon to help make ends meet, and who now sat in rows with pencils and notebooks.
System. Another, more formal and typed, arrived with a new design spec and a request to consult on efficiency for a contractor building vehicles that would no longer be described as improvised. Brackett kept the letters in a drawer, folded and flat, a small archive of praise and an invitation to complicity. He read them and set them aside. When his students asked him what he thought, he would say, "The world will always press what you make into its needs. Your job is to understand how those needs might change and to be ready to refuse." The plant's conversion into other businesses brought a caravan of people through its wide doors. Carpenters taking a bay, a printing concern in another, a small ceramic studio that prized the tall windows for their even light. At first, the town murmured with distrust. The plant had been a symbol of motion, of an industry that required people not to forget how to shape things with patience and force. There were debates at the meeting hall between those who wanted to re-industrialize the plant and those who favored a gentler economy. The elders remembered the press of boots and the bell and preferred the plant's old certainty. Younger families wanted something that didn't smell of oil. The museum curator arranged the stay of the tank fragments like a family reconciled to its scars. She liked objects that bridged hands and history. She hung a rusted track segment so that light could pass through the web of its flaking scales. A plaque explained in sober language that this was a fragment from a vehicle constructed locally, 19. And the display case held a rivet gauge, its edges smoothed by many thumbs. The curator invited survivors to a public evening when the artifacts would be revealed. Tendrils of fog moved low over the river that night. People who had once driven bolts in the machine shop came with their grandchildren on their shoulders. They stood by the glass, their faces reading like a catalogue of labor. Some of them found an expression of pride there, others a look of necessary apology.
At the back of the crowd, Brackett stood beside Ortiz. They looked together at an annotated blueprint, copies Brackett had reluctantly signed off on in the middle of one night, the lines bold and the notes cramped in the margins. The curator read a prepared statement about the ingenuity that arises in scarcity, how necessity reconfigures the tools at hand. She did not dwell on the darker ledger of consequence, but the audience could fill in the blanks. That was the burden of cultural memory. A woman who had nursed in the field stood and said that the vehicle had been a lifeline when ambulances could not pass. And a man who had come from a nearby village spoke of a time when a similar machine had been turned into something that took lives rather than saved them. No neat moral settled the room. People clustered in small groups and spoke in voices that dropped low, as if to preserve the privacy of conscience.
One of the apprentices from the wartime crew, a thin man named Tomas, who had once been the plant's revisionist, someone good at making small improvements where none seemed possible, had taken a job at the ceramic studio. He liked the slow, deliberate shaping of clay. The kiln's tempering reminded him of the furnace's hunger. He taught a youth program on Saturday mornings, showing boys and girls how to throw a pot and how to watch the clay until it told them what it would become. His hands were different now, less calloused for the heavy tools, more precise for the spinning wheel. But his brain kept its engineering rigor. He catalogued failures with a devotion that was almost devotional. The children loved his stories, the ones he allowed. How a badly tempered wheel could shatter under stress. How a tiny flaw in a mold could propagate into catastrophe. He turned those stories into parables of attention and humility. There was a younger generation that treated the manuals and relics as a liturgy of tools. In the back room of the museum, behind the display cases, a group of students from the technical school began an informal study circle. They took apart an old valve housing and traced the flow paths, then tried to reassemble it using modern sealants and older tempering methods. They argued, politely but fiercely, over each step. One of them, a woman named Lena, had a mind for metallurgy and a voice that could quiet a room. She had grown up in the town with stories of men in uniform and the smell of warm oil. She wanted, she said, to make things that would not ask villages to suffer for their endurance. Those who had marched the hardest in wartime carried with them, more than medals, a long inventory of choices that were never neat in the mind. A former foreman named Havel came back to town one autumn and walked the factory floors. He touched a press as if it were a relic of a long-ago body. He confessed to Brackett, in an afternoon of rain, that there had been nights when they had welded in the dark to hide a prototype that could have been used for something different. We were afraid, he said. We wanted to protect what we knew and what we loved. But fear does something else to hands. It moves them faster, sometimes in the direction of less thought. Brackett listened, and then offered something he had written, crumpled and folded in his breast pocket, a short essay on professional responsibility. He passed it across the table, and Havel read it with quiet concentration. The essay began with a simple rule, measure your intent, and went on to argue that every artifact carried with it a set of possible futures. We can only be accountable, Brackett had written, for the ones we can foresee and the ones we can prevent. Not all potential misuse is ours to control,
But our duty is to make the paths of misuse harder, not easier. The town's memory was not static.
System. Students. It was, in its modest way, a civic pulse around an object that had once been urgent and now asked to be remembered. There were books, too, not scholarly tomes, but essays and memoirs. An editor from the region collected oral histories and produced a pamphlet that stitched together testimonies from foremen and seamstresses, from cooks who had served long platoons, and from children who had watched the plant's gates close. People read these pamphlets like talismans. They kept them in kitchen drawers and lent them to neighbors. The pamphlet did not pretend to resolve the moral tangle. Instead, it put faces to the choices, and that was perhaps the more difficult ask, to look into the eyes of those who had shaped things, and to see both pride and liability there. Years later, at a small gathering on a riverbank where the plant's chimneys were only outlines against a low sky, a plaque was dedicated to the workers who had labored there. The plaque was a simple, unsentimental thing, placed near a sapling that someone had chosen for the spot. Names were read aloud. Some of them provoked tears. Some men had never married and were remembered only by their skill with a lathe. Brackett stood in the back and listened. He thought of the torch cooling and the last bench light. He thought of the quiet after the roar, and how that quiet had allowed other kinds of life to take root beside the factory's memory. The story of the improvised tank did not end with a final verdict. It kept living in the hands of those who had built it and in the hands of those who tried to make different things out of the same knowledge. Every time a farmer's plow was tempered correctly and did not fail in the first frost, the knowledge that had taught that temper paid a small debt. Every time a young person learned to spot a hairline fracture and acted before it became a catastrophe, a lesson was preserved. And every time someone used that knowledge to make harm, the community was forced to look at the ways in which necessity could become a siren. On a clear evening, with the river turning to black glass under the stars, a small group gathered at the museum for a late opening. A child, a granddaughter of Ortiz, small and inquisitive, was allowed to touch the edge of the rivet gauge beneath supervision. Her fingers were careful. She turned the object over as if reading a story. The museum's docent, an earnest woman who had grown up with the tinkers and the toolmakers, smiled and told the child what the object had done once. Held panels together under stress, let a stitch of metal keep skin from tearing. "You'll make things with it?" the child asked, looking up with the blunt curiosity only children possess. "We'll learn from it," the docent said. "We learn to ask what we want the thing to do, and then we decide if we can keep it from becoming something else." The child nodded, as children do, understanding the simplest layer of an adult's complicated sentence. Outside, the stars were indifferent in the same way they had been on the night Brackett had turned off his bench lamp. But inside the museum, with hands on metal and mouths that named what was hard to name, the work moved on, slow, sometimes halting, but steady. Knowledge found new forms, communities argued and remembered. The past was neither exonerated nor condemned, but held as if in a tempered clamp, so that it might be examined and, if necessary, reshaped.
Brackett walked home that night with a small packet of photocopies of the letters he had never published, and a cup of tea that had gone cool by the time he reached his porch. He propped himself on the railing and listened to the river, a low, even breath that sounded almost like the mechanical cadence he'd spent his life studying. In the pocket of his coat, he could feel the thin, folded scrap of his admonition. He slid it out, smoothed it with his thumb, and read the line again. "We have to know the reach of what we build." He folded the paper and put it back. If engineering was the promise of behavior, he thought, then the object of a life spent in trade was to be faithful to the small, measurable things, the weld that does not fail, the quench that does what it is meant to do, the promise that the next person to use your work will find it true. From a bench light cooled in another town, a young apprentice took a careful measurement and made a small correction. In a schoolroom, a lecture on tempering was not merely a technical exercise, but a way to teach responsibility. In the museum, a rivet gauge waited for its next pair of hands. None of these acts changed the world all at once, but they were stitches, and enough stitches in time held a different sort of fabric in place, one that recognized both the power of making and the obligation of foresight. And so the work continued, quiet, exact, and reluctant to lend itself to easy summations. The plant's furnace might have cooled, but the techniques lived in pockets, manuals, hands, and the slow accumulation of attention. The town learned, in the way towns do, that ingenuity is a force that must be stewarded as carefully as any alloy. People argued, repented, taught, and repaired. They wrote their marginal notes on the edge of official histories and kept them for the next person who would need to know how to temper a piece of metal without letting it harden into something unforgiving. Night settled, as it always did, and the stars, distant, indifferent, kept watch. Inside workshops, hands stirred, and somewhere a gramophone still played an old tune that made someone smile. The bench light on Brackett's porch wavered for a moment and then steadied. He folded his hands and, without ceremony, went to sleep.